Hello everyone, welcome to the channel. This is your favorite YouTube channel, AI Coding with K. My name is Kshitij. I'm your host today, like always. And just a quick intro about me. I'm an engineering consultant focused on helping startups build AI products using AI. And today we are going to continue with our series of how to use AI as a junior developer, learning how to use AI effectively as a junior developer. So let's begin. We'll move on to the slides and we are go. Okay, great. So this is episode 4. We are going to be talking about how do you control the AI with a phased implementation plan. Okay. In our previous episodes, we have talked about the overall workflow. How do you create a task brief? How do you create a context packet for the LLM? And in this episode, we are finally going to start executing our feature implementation using AI. So, what we are going to be focusing on is how do you approach the implementation using AI, okay, and how much work the agent needs to do, and how do you review the work that agent is trying to do. So we have talked about what is a good way of approaching a feature implementation. You create a great task brief, you create a good context packet, you give all the context information to the AI regarding the task that you want it to implement. Okay, but here is the catch. You can't just say, here is the task, here is the context, implement this. No, you have to approach it slightly differently, because just saying implement this is going to create an uncontrolled chain of events, and you are going to end up with a very large diff. And by that I mean huge number of files updated, huge number of methods updated, database updated, UI updated, tests updated, and all your business logic is all haywire. Okay, this is going to be a huge chunk of change that you will have to go through. What are the issues if you have such a huge chunk? It is hard to inspect, it is hard to verify whether the changes that have been done are actually relevant, okay, and whether you can actually trust all the changes that have been made, whether they are actually useful. Okay, maybe did AI do a good job? Can you trust that if you have 20, 50, hundreds of files that have been modified? Okay, can you verify those changes? And how do you actually go through all the changes, figure out as a software developer? I'm not talking about a coder, I'm talking about a software developer. How are you going to figure out all the changes that have been made, whether they are correct or not? Okay, so the way around this is that you create task in the context like we did in our previous episodes. Now you create a plan. Okay, you just don't say implement this. You create a plan using AI, you review that plan, and then you tell AI to start the implementation. Okay, one thing to note here, and you have to remember this, it is very important. It is far easier and cheaper to review the plan, update the plan, fix any issues within the plan. Okay, I'll talk about what a plan is, but at a high level, plan is basically the exact list of things that the AI is going to change. Okay, You have already mentioned all of these things in the in your task and in your context. Okay, the plan is just a singular document where all this will live. Okay, and it is far easier to review a plan, change any issues that you find in that plan, and fix those issues in the plan. It is far cheaper, because once that implementation is done, right now the plan is just one single markdown file. But the moment implementation starts and the implementation is done, and if LLM ends up touching 20, 30, 50 files, it is changing your UI, it is changing your database, it is changing your business logic, it is changing your tests. Okay, then the review part is going to be very time consuming, very difficult, and very hard to verify. Okay, so, and because planning is so important, almost every coding tool that you use, whether you are using Claude Code, you're using Codex, you're using Open Code, Anti-Gravity, every tool has a plan mode. So you understand the gravity, how important plan mode is, that every single AI coding tool contains a specific mode called which is called a plan mode, because they all understand how important it is for you to create a plan before you actually start the implementation. Okay, now one thing is, so here's a very small example of a prompt of a plan. Okay, you have all the task sprint app that we have been talking about as an example. You have all the changes that you have created in this plan. So for example, the logic that needs to be updated in point 1, the UI update, the business logic update, the tests, and running the verification, and then you say implement the plan. Okay, great, you created a plan, you implemented a plan, but there is still a very big gotcha here. A flat plan, okay, a plan, you created a plan, but that plan is still going to create a large diff. Okay, so I kind of misled you in the beginning when I said that when you say implement this and it is going to create a huge diff and the plan is going to change it. That was a slight misdirection there. It is not the plan itself that is going to save you from a large diff. Okay, it is a phased implementation plan that is going to be the key here. Okay, if you create a simple flat plan, okay, the end result is still going to be the same. The plan is not going to change the end result. If you say create a plan, implement this, okay, it is still going to create a huge diff of the changes. Okay, so a simple plan is not the key here. A plan that is really helpful in saving you from a large diff is a phased plan. So flat plan is you go through the step 1, 2, 3, 4, update the UI, update the business logic, update the database, update the test, verify the test, and that is going to create a large diff. Okay, but if you create a phased plan, then you implement phase 1, verify if everything is working fine, and then you move on to phase 2, verify if everything is working fine, and then so on and so forth. And now what is happening is, after phase 1, you don't have a large diff. You just implemented a small portion of the complete plan, and now you're verifying that small portion of that plan. Okay, and then you are moving forward. So this kind of breaks the whole thing down into small, verifiable, phased implementation. So what is a verifiable outcome of a phase? I've been talking about the phase, you create multi-phase plan, but what is the verifiable outcome? It has to be a coherent outcome. It cannot be like I changed file 1, then I changed file 2, and then I changed file 3. No, that's not really how a phased plan works. A phased plan works in a way where a small portion of the feature is fully implemented, okay, in a and in all the respective places. So whether if there are a few database changes that needs to happen in phase 1, or there's a small UI change, small database change, and small business logic change that needs to happen in phase 1, only those small changes are done. So there's a, and then you can verify it. So it has to be a coherent outcome, okay. It has to be bounded scope, like I mentioned. It has to be a small change happening at very specific set of places, not like everywhere, okay. And then it has to be, it can be verified easily and meaningfully. It's not like there are no, you aren't able to figure out what are the changes that were done and whether they are working fine or not, okay. So these are the things that the phase outcome of the phase should be verifiable. And the last but not the least, there should be an end goal of that phase. So it has to be like a very small phase, because if one phase in itself is very large, you'd rather have that phase broken down into sub phases, okay. So the way it works effectively is only when you have very small set of scoped verifiable outcome based changes that you are doing, okay. Let me repeat that: small scoped verifiable outcome based phased plan, okay. Now like I was talking about, it has to be a coherent change, okay. It's not like in phase 1 I'm going to update 2 files, and in phase 2 I'll update the 3rd file. No, it has to be coherent, it has to be classifiable, it has to have, in our example, if the UI is changing and the business logic is changing, then the respective tests are also changing according to that, and those tests are being verified and reviewed, okay. So it has to be small, a very bounded scope of work that needs to be done. So here is an example. Our plan of the demo app that we have been trying to build is that we need to add labels to our tasks, okay. So one requirement is, what is a completed task, okay. It needs to say done, and the test case is completed task return done, okay. So so in one phase, if you have like one requirement and then you have a change that needs to be done, and there is a respective test case for it. So these are all the phases and examples of the test cases that need to go through, okay. So what additional thing that you can do to really know how things are going along is basically you have phases and you have goals for each phase, okay, and then you have a tracker inbuilt inside your phased implementation plan, okay, so that LLM can keep track of, I'm done with phase 1, now I need to move to phase 2, and then I will work on phase 3, okay. So phase 1 is done and verified, okay. So let's take an example like it is showing on the scene. Phase 0, the goal is baseline, set the baseline, the status is verified, and the evidence is that all the test cases have passed. That is the verification evidence, okay. Phase 1 classification policy, basically about the task labels. It is work in progress. There is no evidence of whether it is done or not, so it is pending. Phase 2, not started, blocked by phase 1. Phase 3, not started, blocked by phase 2. So you have a proper tracker. So you create a phased plan and you add a tracker within that phased plan so that the LLM knows exactly the current status of the plan, and then you can use multiple LLM agents to go through this plan and implement it. Okay, so but before we go into that, one very important thing is implementation. Implemented does not mean verified. Writing a code by itself does not mean that it is A, working properly, B, the business logic or the UI or the database that change impacts is not breaking anything else. Okay, so you need to verify whatever changes have been made. How do you do that? You write tests, you run test cases, unit tests, implementation tests, end-to-end tests, whatever. But remember, implemented does not mean verified. Okay, so a code can exist, evidence is pending, a proper phased tracker inside the implementation plan will always tell you whether it is verified and what is the evidence that it was whether the verification is complete or not. Okay, so now what you are going to do is you are going to use this phased loop. So it's kind of a loop now. So you've created a plan. It is a phased plan. It has a tracker inside it. You have 4 phases. You start with phase 1 or phase 0, whatever. Okay, you go through that phase, implement it, verify it, check whether everything is done. You review the code, you verify the code, you run the test cases, you do all of those things. Okay, and then you move on to phase 2, repeat the same set of steps. You move on to phase 3, repeat the same set of steps. So now what you have done is you have created a phased loop for the actual task, for the feature that you wanted to build. Okay, so you have an input, you have a target, you have a boundary, and you have a whatever questions that or changes that you are trying to make. Okay, so here is a prompt that you can use today to create a plan. Create a phased implementation plan. Do not modify any code yet. Focus on creating the plan only. Okay, these are the things that you need inside each phase: the outcome, the boundary, with the verification steps, and the stop condition. Okay, and then you explicitly tell it to create a tracker so that the phases can be tracked, which phases are done implemented, which are not done implemented, where the implementation is pending, whether they are verified, is it still in progress. Okay, and if there are still any questions, mark them as unknowns. Okay, here is the example of the app. So the outcome for phase 1, okay, is due date classification is correct. That is the outcome. The scope is the due date policy file and the test cases. Okay, behavior that are done, overdue, due today, and upcoming are properly managed. Okay, verification, run the test cases, and you stop that when the verification is done. Okay, why are we doing all of this? You will say, Kshitij, you have been talking about like creating task brief and creating task context and creating a phased implementation plan, and it's so much work, and now you're telling me to add a tracker and creating a phased implementation and plan. Why? See, coming back to the original idea of, if you implement this and it creates a large diff, it is too much of a change for you to verify, control, and manage. Okay, this phased implementation plan reduces the blast radius of any eventuality where things go wrong. Okay, things will go wrong. Even after everything you've done, even after everything you have prepared, LLM is going, whenever you are coding by yourself or using an LLM, things are going to go wrong. But there's a difference between impacting us 3 files rather than 30 files. Okay, a large diff, 30 files, something went wrong, you're going to go crazy trying to figure out where the issue came in, why is it happening, how do I fix this. It is very, very, very difficult. On the other hand, if you have 3 files that have been updated, you know exactly where, if anything goes wrong, where it went wrong. Whether the changes that you made impacted the existing code in a way where the existing code stopped working, or the implementation that was done that stopped working, or you have to change your assumptions, change your plans around, okay, you did not really think of, okay, this change is going to impact this one, now I have to like figure it out again. So anything could go wrong, but the impact radius, the blast radius is going to be very, very small, very, very controlled, very easily verifiable and testable. Okay, so if you have a small plan, like you have files, behavior, scopes, everything nailed down in a very tight progression. Okay, so here is the prompt. Once the plan is implemented, the previous prompt that I gave you is how to build a plan. This is the prompt for how do you go about executing the plan. Now we are finally going to come to the part where we are actually going to generate code, have the feature implementation start. Task brief, done. Task context, done. Phased plan with the tracker, done. Now we are going to start the implementation, implement phase 1, and you have your context, you tell it what needs to be done and how do you control it. Okay, even though plan already has it, I think I made a mistake. I shouldn't really have added so much detail. You can just go about and say implement phase 1. Okay, but you have to tell it that only implement one phase at a time. That is the most important thing. So once the implementation is done, how do you trust what the changes were made? Okay, you have to review the code that the LLM updated. It is on you to review the code, to figure out if everything is as per the requirement, as per the boundary that you had clearly set. Okay, were the changes within the same bounds you had specified? Is it making any hidden assumptions? Is there any dependency changes that it had done? And whether you understand what changes were made. Okay, it's not going to be like AI coded it, AI understands it, I don't know what is happening. That's not how things work. You are a software developer. Your job is to review the code. Your job is to control how AI is working. Because there is one important thing which is going to come that I'm going to talk about now. Okay, and that is, so this is the verification step. So the change is done. Now you're going to find the evidence whether the changes that have been done, they are verified and they are correct. Okay, you reviewed the code. If anything fails, you change, you figure out if there was any drift or not, or is there any unknowns or hidden assumptions that were made. Okay, once that is done, then you say that it is verified. Now the thing that I was going to talk about is, once one phase is done and verified, you just don't jump to phase 2 immediately. No. Don't do that. Reason being, while the phase 1 was being implemented, there is a very high possibility that something changed that will impact the next coming phases. So you have to be very careful here. You implemented phase 1. You verified everything, you reviewed the code, you ran the test cases were run, and you have the evidence that phase 1 is done. Now you have to review from what the changes were made. Does phase 2 stand as it is, or whether phase 2 needs to be reviewed again? Are there any assumptions that changed? Are there any places that you did not anticipate while the plan was being built? When you reviewed the plan, there might be some changes that phase 1 did that we did not anticipate, and that might impact how the phase 2 or 3 or 4 are going to move forward. Okay, so now what you need to do is you need to review phase 2 again, do a quick review, check whether everything is working out, approve, and then you move on to the next phase. Now that loop is done. Okay, so you create a plan, a phased plan, you implement it one phase at a time. See, you need to slow down. What we are basically doing here is we are doing all this preparation of task brief, context packet, phased implementation plan. Okay, and you might feel like, okay, now I need to give everything to AI and let it implement everything and I'm done. No, but see, you need to slow down here. And this I'm talking to you, and I'm at the same time telling it to myself as well, because we all have to remember LLM is doing the majority of the work. The implementation that would have taken you hours or days or weeks is now being done in a matter of minutes. Okay, you are not in a hurry to finish the job. Slow down, let things move slowly so that you can be effective and not run into issues that you might regret later on. You're already way ahead of what a standard implementation would have. If you have gone through a standard implementation, again, it would have taken you days or weeks of coding, planning, writing the documentation by hand. Okay, all of those things are out the window. Now you are talking about all these things in a matter of minutes. From the point of creating the task brief, it took you a few minutes to figure out, convert that one line into a paragraph of task brief, taking the task brief and adding a few more lines of additional task context, giving that to an LLM and telling it to create a phased implementation plan. Take 5-10 minutes, review that plan. Okay, tell AI to implement one phase, review it, take it slow, review it, let it see what the changes are happening, understand what is happening, because till now you've hardly spent what, half an hour, 40 minutes in coming to this, and that is like, I'm telling by a stretch, half an hour, 40 minutes. Okay, that half an hour, 40 minutes is nowhere compared to how much time it would have taken in terms of days or weeks and hours over a period of a week. It would have taken you 30-40 weeks. 30 minutes over 30 hours is nothing. So slow down, take some time, go through the process of planning for each phase, implement it, inspect it, verify it, track that change, or rather AI will track it in the implementation plan, update it, review the next phase, and then go back to the loop. Okay, so some of the common failure modes that tends to happen is that you might feel plan mode is too much of a ceremony. I'm not gonna do that. It's way too much for me to handle. That's something that you might think of taking a shortcut here, but it's not going to be helpful at all, because we have already discussed this and it's not going to be helpful to anybody. Okay, one flat plan, like I mentioned, planning is not going to change the amount of code you are going to generate. Okay, planning is just here to make it more effective for, or rather planning only works when you do it in phases. Otherwise, the task that you have already created, a task brief and a task context, planning is not going, creating a plan is not going to change the amount of work the LLM needs to do to implement that feature. Okay, so don't think that planning is there to reduce the work. It might increase the accuracy, but the work is not going to reduce. The work is amount, the feature implementation that the feature that we want to build has to be implemented, and that the amount of code changes that feature implementation is going to do is not going to change. The only change that we're talking about is doing it in phases, in smaller bursts, so that we can verify those smaller set of changes. Okay, that is all that is going to change. Okay, so again, some of the common mistakes are large phases, file-based phases instead of outcome-based phases, done without evidence, no verification. You just the LLM marks is done, does not run the proper test cases. You did not test everything properly. You did not review the changes that were done in that phase. Okay, and then the other mistake is like I mentioned, agent continues to the next phase automatically without you taking a moment to review whether the changes done in the current phase, whether they impact the future phases or not. Okay, and then the tracker is not really being used properly. Now, we are about to come to the end. So the whole control stack is, in episode 2 we talked about controlling the task, in episode 3 we talked about controlling the context of the task, and now we are talking about controlling the execution. It is all about controlling LLM, letting it stay and work within the set bounds that you have, okay, and not letting it go haywire. Okay, so one important thing is phasing does not replace task framing or context. It protects both while the agent writes your code. So this is a very important statement that I wanted to share here, because all the preparation that we have done till now is only telling LLM what to do, where to do, and now we are telling it exactly in which steps you need to do those set of changes. Okay, so everything has its own place. The task brief has its place, the task context has its place, and the phased implementation plan has its own very special important place. Here is a very quick visual summary of what we have talked about today. So you have the plan mode, you create a scope constrained phased implementation plan, you create the phases. You have phase 1, you have smaller chunks of verifiable coherent changes. So you have phase 1 and phase 2, and then you verify them, and then you have the task tracker of what is verified, what is just implemented, not verified, what is still in progress, and what is TBD, to be done. Okay, so this is a visual implementation of plan first, execute in phases, and track your progress very clearly with the evidence of verification. So, or whether it has been verified that everything is working fine or not. So that's the important bit. And yeah, we are reaching to the end, and in the next episode we are going to be talking about debugging issues using LLM. Now you have done the implementation, your feature is implemented, but oops, there are issues in the implementation. You have to figure out what needs to be fixed, how it needs to be fixed, we are going to be talking about in the next episode. So I hope you like this episode. I would request to give a thumbs up and subscribe to this channel if you're really learning a very important aspect of being a junior. Even though you are being a junior developer, you are learning how to use AI effectively. Join my Discord. If you have any questions, you can contact me directly on my Discord, or you can write a comment down below. And yeah, see you in the next episode. Take care. Bye bye.